Okay, so this is our review list for the Math 21. Okay, Math 21. So in the beginning, we talk about complement set, union, and the intersection of sets, right? Union of intersection of sets. Okay, so first, what is the intersection, right? So A intersect B, so that means one element in A and in B, right? And in B. So now you look at 1, 3, 5, 5, 6. So their common element is 5, right? So this is common elements. So that's the idea for intersection, right? That's the idea for intersection. So the answer is 5, right? So now what is A union B? A union B is the set of all elements in A and the set of all elements in B. So we put these two sets together. So 1, 3, 5 is in A, 5, 6, 7 is in B. So the union is 1, 3, 5, 6, 7, right? 6, 7. Okay, so that's the union and the intersection. Okay, union and intersection. So now what is A prime? A prime is all the elements in U minus all the elements in A, right? So it's in U but not in A. So what is in A? A is 1, 3, 5. So you delete 1, 3, 5. You got the complement. So complement is 2, 4, 6, 7. Okay, so similarly you can get the B complement. B complement is everything in U minus everything in B. So you delete 5, 6, 7, you got 1, 2, 3, 4, right? You got 1, 2, 3, 4. So that's B complement. Okay, yeah. So now A complement union B, right? Union B. So now we need everything in A complement and everything in B, right? Everything in B. So 2, 4, 6, 7, that's in A complement. And then we also need every complement, every element in B. So 5, 6, 7 in B. So we got 2, 4, 5, 6, 7. We put elements in A prime and in B together, right? B together. So now what's A complement intersect B complement? So that's the common element of A prime and B prime, right? So their common element is 2 and 4, right? 2 and 4. 6, 7 in A prime, but not in B prime. 1, 3 in B prime, but not in A prime. Okay, yeah. So again, intersection means common elements, and then union means all the elements in A, all the elements in B, you put them together. Okay, and then complement set means everybody minus the one in the set A, right? In the set A. Okay, so that's the first part. So now the second question is about the Venn diagram, right? Venn diagram. Okay, so we imagine we have two circles. One is A, one is B, and then another way to think about these two circles, we have three parts, right? 1, 2, 3, right? 1, 2, 3. Okay, yeah. So now what is part 2? Part 2 is our first question. So that is in the common part of A and B, so is the intersection, right? So now what is A union B? A union B will be part 1 plus part 2 plus part 3, everybody in these two circles, right? In these two circles. Okay, so now what's A complement? A complement will be U minus everything in A, right? Everything in A. So now my picture is slightly wrong, right? Slightly wrong. So it should be this part, right? Minus the whole circle, okay? Minus the whole circle, okay? Yeah. So 2 is in A, so it's not in the complement, okay? Not in complement. So similarly for the complement of B, so that's everything in the rectangle, but not in the circle B, okay? But not in the circle B, okay? So that's the easy understanding of different parts in the Venn diagram for two circles, okay? For two circles. So now after that, we will change our questions. Based on the word questions, we will make our own Venn diagram, right? Own Venn diagram. So step 1, you draw. So in the exam, I think I gave you the structure, right? A rectangle and then two circles, okay? Two circles. And then you read the question, you know, okay, so there are total 500 students. So U has 500 students. Cardinality of U is 500. Okay, that's the total of the students in the rectangle, right? Rectangle. Okay, yeah. And then we have two properties. So 300 wear necklace and then 200 wear ring. So now you know the meaning of these two circles, right? So this is necklace and this is ring. Okay, yeah, but some of them may wear both. That's in the middle, right? That's in the middle. So now still call these three parts, right? Still call these three parts. Okay, now look at only like two circles. Look at these as three parts. Okay, yeah. Okay, so now 300 is what? 300 regularly wear necklace, so 300 will be 1 and 2, right? And then 200 wear ring, so 2, 3. Okay, 2, 3. Okay, and then the last sentence, 125 wear a necklace and a ring, so 125 means part 2. Okay, part 2. So we look at these 3 parts to make a Venn diagram, and then we can solve the question, right? So now we know the middle part is 125. Okay, yeah. So now what is necklace? Necklace will be 1 plus 2, so necklace 300. This equation will be the new equation, part 1 plus 122. So what's part 1? So 300 minus 125 will be part 1. Part 1 is 175. Okay, so that's how we get this 175, right? 175. So now similarly, so let's change the color. So for 200, the ring, right? 200. So 200 is 2 plus 3, and then part 2 is 125. So 125 plus 3 will be 200. So part 3 will be 200 minus 125. So part 3 is 75. Okay, it's 75. Okay, so now we know these 3 parts. Part 1 is 175, part 2 is 125, part 3 is 75. So after you make this new diagram, okay, so now what's outside these 2 circles? Okay, what's outside these 2 circles? You have to add 1, 2, 3. So 1 plus 2 plus 3 now is 175 plus 125 plus 75. So this is 375. Okay, so outside this means the total 500 minus 375, we got the 125 there. Okay, we got 125 here. Okay, so that's the calculation, right? The total 500 minus these 1, 2, 3 parts, you got the complement of these 2 circles. Okay, so that means those students not wearing a ring and no necklace. Okay, and no necklace. Okay, so now let's look at part B and part C. How many students regularly wear a necklace or a ring? Okay, so this will be part 1, part 2, and part 3. So this is 375. How many students wear a necklace but not ring? So that means in the necklace but not in the ring. So this is part 1, right? This is part 1. Okay, yeah. So after you make the Venn diagram, you change the sentence to one part of the picture, right? One part of the picture. Okay, yeah. So let's look at next one. Next one is similar. Okay, next one is similar. So I'm going to just use the Venn diagram here, right? So we have 3 parts, right? We have 3 parts. Okay, so now let's read. The total is 428. So cardinality of U is 428, right? Yeah. So that's the whole rectangle. And then 214 purchase. So that's the total of 1 and 2. Okay, so you change this given sentence to the parts, right? And 299 satisfied. Satisfied is 2 and 3. Okay, yeah. And then 52. 52 is made a purchase and not satisfied. Okay, made a purchase, not satisfied. So that's part 1. Okay, in the purchase circle, but not satisfied. Okay, not in the satisfied circle. Okay, so this is part 1, 52. Okay, so this example, we got this part first, right? We got this part first. Okay, yeah. So now if you look at this 214 is 1 plus 2. So now number 1 is 52. So 52 plus 2 will be 214. So part 2 is 214. 214 minus 52. We got 162, right? So that's exactly this calculation, right? This calculation. Okay, yeah. So now you got part 2. Part 2 is 162. So use 299 minus 162. You can got part 3, right? You can got part 3. Okay, part 3. So now what's the complement of 1, 2, 3? You use the total minus these 3 parts. You got 77, right? You got 77. Okay, yeah. So now we know these 3 parts and then 77 outside. So now let's read question B. How many made a purchase and then satisfied the middle, right? In 2 circles. Okay, And then C, made the purchase or satisfied. So this is 1, 2, 3. Okay, so this is part 2. So this is intersection, this is union, right? This is union. So now part D is satisfied but did not make a purchase. So this is part 3. Okay, part 3. And then not satisfied and did not make the purchase. So this is not in the circle, right? Not in the circle. So the last part. Okay, the last part. So that's the Venn diagram. Okay, we have intersection, union, but the important thing is make them look at 3 parts. You figure out 1, 2, 3, how many cardinality are part of 1, 2, 3, then you can solve the problem. Okay, yeah. So after that, we have a lot of multiplication questions, right? Multiplication, first thing, we define factorial. So n factorial is the product from 1 to n, all the integers, until you got n minus 1 and n. You multiply all the integers between 1 and n. That's factorial definition. In this example, 5 factorial. So you multiply every number from 1 to 5, you got 120. Some calculator, you just click 5 and click factorial button, you got 120. And this is a division, right? This is division. So now there are 2 comments, right? 0 factorial is 1 and 1 factorial is 1. Okay? So these 2 new definitions. Okay, 2 new definitions. Keep that in mind, right? Keep that in mind. Okay, so now what's the next question? Next question is the multiplication property, right? Like I flip 3 coins. So each coin has 2 cases. So the total number of cases will be 2 times 2 times 2. Okay, so if you do a job and there are several steps, right? We multiply the possibilities, the ways that you do each step. We multiply all the numbers for each steps to get the total number of different ways. Okay, different ways. So now this is a certain model of a truck, right? Of a truck. So you choose outside color, inside style transmission, and there is 2-wheel or 4-wheel drive. Okay, so there are the steps, right? You have step 1, pick some color outside, 2, 3, 4, and 5. So you have 5 steps to make a combination to select your car online, right? Yeah. And then after you make the selection, the company will make it for you, right? Make it for you. So now step 1, you have 5 different colors, outside colors. Step 2, you have 3 different colors. Step 3, 3 styles, and then 2 transmissions, and then 2 ways, 2-wheel or 4-wheel drive, right? Yeah. So this is the possibilities, the choices for each step. You multiply all of them, you got a 180. Okay, you got a 180. So that's the multiplication. Okay, that's the multiplication. Okay, yeah. And then later we will talk about NCR and PNR. They are just extended way to multiply, right? Multiply. Okay, yeah. So now the difference between combination and the permutation is the selection is ordered or unordered. If it's unordered selection, you use combination, NCR. If it's an ordered selection, then you use permutation. Okay, then you use permutation. Okay, yeah. So if you don't know it's under ordered or unordered, just write down the example, and then you can see if it's the same result, then unordered selection. If it's the different result, it's ordered selection. So let's look at number 7. So there are 23 students, so this is the n, right? And then choose how many? Choose 3, right? Choose 3, so this is R, right? Choose 3. Okay? To give speech in a school competition. How many different ways can teacher choose a team? Okay, we choose a team. So now you say, okay, so maybe the first choose ABC. That's make a team. And then we change the order. Teacher first pick A, pick B, and then pick A, and then pick C. So they are the same team. So that's unordered selection. Okay, unordered selection. Okay, yeah. So first one, teacher pick student A first. Second one, teacher pick student B first. But eventually, it's a team of these 3 students ABC. Okay, so it's unordered selection. And then N is 23, R is 3. So we got the answer is 23, C3. 23 students, choose 3. Okay, choose 3. So sum calculator, you just click that button, you got 1771. So if you don't have that calculator, you can use this formula, click factorials, and use factorials to get the answer. Okay, but when I grade your exam, mainly I just look at this notation. Whether you know it's a combination or permutation, and then what's your N, what's your R. Okay, what's your N, what's your R. Okay. Okay, yeah. So number 8 is a permutation. When number 8 is a permutation, pay attention to this. It's a taste sequence, right? Taste sequence. So we select 4. So select 4, that's R, from 7, so that's N, right? So we have 7 dishes. We select 4 to taste sequence. So if you pick 1, 2, 3, 4, that means you will eat number 1 first, right? If you switch the order, 2, 3, 1, 4, it's same 4 dishes, but this sequence changed. You will eat number 2 first. So different order give you a different sequence, right? Different sequence. So it's an ordered selection. Okay, you cannot use 7C4. You have to use 7P4, right? So this is N, this is R. Okay, this is R. So if you choose some numbers, choose something from a larger group, consider its combination or permutation. Unordered combination, ordered permutation. Okay, ordered permutation. Okay, so now this is just a special way, right? It's just a special question. Okay, how many different ways you can arrange this letter? Okay, you can arrange this letter. Okay, yeah. So this is somehow a little bit harder than permutation. Okay, the order matters, right? The order matters. AF. So if you change the order, F, A, change the order of 2 letters, you will get a different combination, right? Different permutation. So this is a permutation. It's an ordered arrangement, okay, of the letters. Okay, arrangement of the letters. Okay, yeah. But this one is, we cannot use NPR or NCR. We have to use this special formula, right? Special formula. Okay, yeah, and it's easy. First, you count how many given letters. So in this word, we have 6 letters, and then you only look at the repeating part. There are 2F, then the repeating part is the factorial in the bottom. Okay, 6 letters on top, right? And this is the first repeating letter, so you divide it by 2 factorial. So now if you have 2 repeating letters, right? 2F, 2E, so still 6 letters on top. And then 2F give you this 2 factorial down here, and 2E give you another 2 factorial down there. Okay, so if you have more repeating letters, you just have more factorials in the denominator. Okay, in the denominator. So now what about if there's no repeating letter? Okay, the last example, Bronx has no repeating letter, then you don't have division. You just have 5 on top. Right? So if you still want to use division, this will be 5 factorial over 1 factorial. So it's the same. 1 factorial is 1, right? 1 factorial is 1. Okay? Yeah. So that's the word question. Okay? Give you a word, how many different ways you can put the letters. Okay? Different permutations. Okay? Different permutations. Okay? Yeah. So if you have 3F, then this will be divided by 3 factorial, right? If you have 2 more E, 2 factorial. Okay? Yeah. So N is just how many letters in the beginning. Okay? How many letters in the beginning. Okay? Yeah. So now for this question, we have 2 different ways to solve it, right? So first you can use the addition formula. So PA union B is PA plus PB minus PA intersect B. If you can remember this formula, right? Remember this formula. So there are 3% given in this question. Then you realize, okay, maybe that's the question for this formula, right? And then you rate it, right? You have to know what's A and B, right? A and B. So here they wear watch and earrings, right? Watch and earrings, that's your A and B. So A is watch, B is earring, right? And then you rate, what's 58.3%? That's the watch, right? 54.1% earring. Okay, and then the last one, 50%, they wear both, right? That's the intersection. So and always means intersection, right? Means intersection. So now they want to find or. So and is for intersection, or is for uni. Okay, uni. So A and B, A or B. So that means A intersect B, A union B. Okay, A union B. And then you just use the formula. So percent of watch plus percent of earring minus percent of intersection is equal to the union. Okay, is equal to the union. Then you got 62.4%. Okay, so that's one method. Okay, that's one method. So what's the other method? The other method is you can build a Venn diagram, right? You can build a Venn diagram for this, right? You can build a Venn diagram for this. So it's the same idea. So you got a rectangle, and then one is watch, one is earring. So we use W and E. Okay, so now we have three parts, right? We have three parts. Okay, yeah. So now part 1 is watch. So we got 1 plus 2 is 58.3%, right? Let's skip the percent notation. And then earring is 2 and 3. So in the Venn diagram, so this is 54.1%. Okay, and then part 2 is their intersection, 50%. So now we know this is 50, right? This is 50. So part 2 is 50. So this is 50 plus part 3 is 54.1. So part 3 will be 4.1. 54.1 minus 50, right? And then this is 50. So part 1 plus 50 is 58.3. So part 1 is 8.3. Okay, 8.3. So now what's their unit? Their unit is 1 plus 2 plus 3. So you got 8.3 plus 50 plus 4.1. We got the same answer. Okay, we got the same answer. So you can either use the unit formula or you can use these three parts Venn diagram to solve this number 10. Okay, to solve this number 10. Okay, so now this number 11 is the birthday question, right? The birthday question. So you have to understand the numerator, the denominator, and then when we use 1 minus, right? When we use 1 minus. Okay, yeah. So first, we want to see the probability of same birthday. So same birthday is too hard to consider. We consider the complement event, which is different birthday, right? Suppose 16 people, they all have different birthday. Okay, you find that probability, and then 1 minus that, or 100% minus that, you get the percent of same birthday, right? Same birthday. Okay, so now probability of E prime, so we have denominator. Denominator just how many times you multiplied by 356 days, right? Every people have 365 choices, and you have 16% for this example. So this is a repeating multiplication, so that's the 365 to the 16th power. Okay, and the numerator is we have 16 different days, right? Because they're different birthday, right? So if we choose 16 days from a year, so which is 365 days. So permutation, because different order give you different choices for the first person, right? The day will change, the birthday will change if you switch the order, right? Yeah. Okay, yeah, so it's fixed. The first day you pick is for the first person, second day you pick is for the second person. You cannot switch them, okay? If you switch, their birthday change. So it's a permutation, not combination. Okay, yeah. So this is the probability for different birthday. So now we need two of them have the same birthday. So you need 1 minus this different birthday. You got probability of same birthday. Okay, same birthday. So the calculation, the number is not that important. This expression is important. Okay, you should remember there are two steps. First, we change to different birthdays. Okay, that's a permutation selection. Select that many days from a year. That's numerator, and the denominator just repeating product of 365. Okay, 365. Okay, yeah. So now permutation for birthday, and then lottery is combination, right? Lottery is combination. So here I gave you two examples, right? So we choose 5 numbers from 52 numbers. So this is n, and then this is the winning number, right? This is the winning number. Okay, yeah. So this is the R for denominator, right? Denominator. So what's how many possibilities you can make a different winning number? 52. We choose 5, right? We choose 5. Okay, and the lottery is combination, right? You match all the numbers. The order doesn't matter. That's the rule, right? That's the rule. Okay, yeah. So now how do you win first prize? You have to match exactly the same number, right? Exactly the, so suppose the winning number is 1, 7, 4, 11, 50. Okay, you have exactly the same 5 numbers you win. So there's only one way you can win the first prize. Okay, has to be these 5 numbers. Okay, all other numbers you will not win the first prize. So numerator is 1. Okay, so now to make a more general calculation, I also give you the second prize. So what's the second prize? Second prize is you match 4 numbers. Okay, so now let's still use these 5 winning numbers. Okay, yeah. So now we have two groups. These 5 numbers is the winning numbers, the other 47 losing numbers. Okay, so what's second prize? Second prize means you choose 4 from these 5 winning numbers. That means match 4 numbers. And then the 5th number you choose from the losing numbers. Okay, yeah, so except the first prize, you have 2 groups. You choose 4 from winning side and then choose 1 from the losing. So if this is third prize, match 3 numbers, you will choose 3 from 5 winning numbers and 2 from this 47 losing numbers. Right? Yeah, so that's common, that's the idea. Okay, so this is a harder part. Okay, this is the harder question. Right? Yeah, but they have the same denominator. This is how many ways you can make the winning number. Right? Yeah. And this means 5, choose 4 winning, and then this means 47, choose 1 losing number. You put them together, you'll win second prize. Okay, second prize. So now what is third prize? So this will be what? This will be 5. You match 3 numbers. You choose 3 winning numbers, and then 47, you choose 2 losing numbers. Right? That's numerator, and then we got same denominator. 52, choose 5. Right? 52, choose 5. And you can ask any questions, right? More questions. Fourth prize, fifth prize. Yeah. Okay. So again, first the question is permutation, combination for the lottery. Okay, for the lottery questions. Okay. Yeah. So the last topic is 3 ways to get the average, right? Yeah. So you will be given frequency tables. So for first question, you just list all the given numbers. Right, all the given numbers. So they said you got 4 number 8, 2 number 10, 5 number 11, 3 numbers 13, 1 14. You list them, right? Yeah, from smallest to largest. Okay, smallest to largest. So now what's median number? Median number means who stand in the middle, right? Yeah. So you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right? 15. So there are 15 numbers. So this is the 8th number in the middle. 7 this side, 7 the other side. Okay, 7 the other side. So what about if there are 4 numbers who is standing in the middle? So let's say 5, 10, 10, 13. Right, then we consider 2 of them in the middle. Okay, so the median will be 10 plus 10 over 2. Okay, we find the average of these 2 numbers in the middle. If you have 2 numbers standing in the middle of the list. Okay, of the list. So that is the definition of median. Okay, so what's mode? Mode means which one appeared the most. Okay, yeah. So we have 5, 11. So that's the winner. Okay, that's the winner. Which number you get it the most often? That's the mode. Okay, we don't care. Is the median the smallest, or maybe it's the biggest, or maybe somewhere in the middle, right? So if you change frequency 8 to 6, you add 2 numbers 8. Okay, yeah. So then the mode will be 8 because you have 1 more 8 than 11. Right, 1 more 8 than 11. Okay, yeah. So now they are the median and mode. So what's mean? Mean means you add everybody. So that's the total of the top. Total of all given numbers. Right, you got 160 and then divided by how many numbers you're adding on top. Right, yeah. So you just add all of them. If you don't understand my formula for the multiplication, right? Multiplication. Okay, yeah, and then divide. So now what I wrote here is the number times the frequency, right? You have 8 number 4, so 4 times 8. You have 2 number 10, 10 times 2. 5, 11, 11 times 5. 3 number 13, 13 times 3, and then plus 1, 14, you got the sum. You will get the same sum, okay? You will get the same sum, okay? Yeah. So 160 divided by, we're adding 15 numbers on top, so it's 10.67. So in the class, we'll have more practice about this. Okay, median, mode, mean. Okay, median, mode, mean. Okay, so now the number 14, they give us the number, the value, right? This value, this x is repeating. So now number 15, they give us a small interval, right? So we only know 2 of the numbers are between 5 and 7. In this list, okay, maybe it's 5.5 and 5.7, maybe it's 5.9, or maybe the other one is 6.9. We don't know which 2, but we know between 5 and 7 we have 2 numbers. So this is the case. We use midpoint. Okay, we use midpoint to do the calculation. Okay, yeah. So 5 and 7 plus 2, we got middle value 6, and then we have 2 of them, so it's 6, 6. 7 to 9. We have 5 of them, right? 7 to 9. What's the middle value? 8. So we have 5 of them. So we got that. Put the list down here. 6, 6, 2. And then we have 5, number 8. Okay, we use middle value for the interval, okay, for the small range. So now we have 3 numbers between 9 and 11. 9 and 11, the middle is 10. 9 plus 11 divided by 2. And then we have 1 number between 11 and 13, so that's 12. Okay, yeah. So we use midpoint if we don't know which number actually given. Okay, given. Okay, yeah. So we just use midpoint to calculate the same average, right? The same mean. So this is the formula of mean, right? The sum, you add all these numbers divided by how many numbers we are adding. So this will be 94 over 11. Then you got that number. Okay, you got that number. Okay, so at the end of the review list, we studied median, mean, and mode. Okay, median, mean, and mode. So that's it. That's our review list.